all you fantastic people, and welcome to Maths. Today I'm going to be introducing you to one of my homies, Algebra. To me, Algebra is both my mathematical foundation and my unrealistic paradigm of masculinity. As some of you might have guessed, today we're going to be talking about algebra. Like algebra, it may seem like a giant to tackle, but I assure you, approached properly, it's a gentle giant, and one that allows all math moving forward to rest upon its shoulders. So what even is algebra? Why is it useful? Well, algebra gives us more tools to find the unknown. In math, we won't always have 5 plus 5 equals 10, where we have recognizable numbers on one side being combined in some way to make another number. There's always uncertainty in real life. For example, how long it'll take you to go to the grocery store, if the milk is on sale or not, how many leaves are on a given tree. Algebra takes us a step closer to being able to deal with that uncertainty and change. Algebra also allows us to deal not with just numbers, but patterns, such as dealing with only numbers with 5s in them, or only even numbers. Much of the world behaves according to patterns, like the number of petals on a flower, or seasons, or male pattern baldness. So we'll be able to deal with patterns and change. But where might this be useful? Pretty much everywhere. I'm talking biology, chemistry, physics, history, psychology, geology, weather, astronomy, construction, sociology, statistics, medicine, engineering, computers, video games, crime solving, puzzles, teaching, money, real estate, politics, accounting, electricians, cars, anthropology, the list goes on and on and on. Alright, well I think I've hyped it up enough. Its usefulness will become more clear the more we go into the specifics, so on to the next section. Alright, so what's a symbol? Well, a symbol represents something. We encounter them all the time. For example, emojis. We use emojis as symbols for the emotions that we're feeling. We have the happy face, which represents when we're happy, when we're joyful, when we're in a good mood. We have the crying emoji, which represents when we're sad. I use it all the time. And we have this one, which is a personal favorite of mine. It represents Easter Island and... well, I just like it, to be honest. Another example would be flags. They symbolize their country. I live in Canada, so when I see a flag with a maple leaf on it, I think, hey, that's Canada. And cars. Cars are symbols for travel. When you see someone in a car, or when you just see a picture of a car, you think of travel, because it moves you from one destination to the other. So these may seem pretty obvious to you, but what might feel less obvious is that numbers are actually symbols too. Let's look at number 1. 1 is just a straight line that we draw, but it represents the idea of oneness or one thing. Oneness can be applied to one apple, one fidget spinner, one person, and it allows us to talk about anything that is one. The symbol 1 is more versatile because we don't need to have a specific context of an apple, fidget spinner, or person to understand the notion of one thing. We can do the same thing for 2, 3, and any number as well. 2 representing 2-ness, 3 representing 3-ness. We don't need a specific context to understand it. Symbols thus take a concrete thing and abstract them. They make it more versatile. Now this word I just used, abstract, is very important because mathematicians use it very frequently. Lots of math aims to take specific cases and make them more general so we don't always have to refer to those individual contexts. So we abstracted the idea of oneness so we don't have to refer to an individual context because we're just using one. We can do the same thing with operators, such as addition. The idea of addition is that we're combining our values. If we say 1 plus 2 is 3, this could be 1 fly plus 2 flies is 3 flies, or 1 ocean plus 2 oceans is 3 oceans. But we say 1 plus 2 is 3 because it's more general. It generalizes or abstracts the idea of combining one thing and two things. So because it's more general, it's more abstract, and therefore it's more convenient to talk about. So in algebra, we can do the exact same thing. We can abstract numbers. So let's make up a symbol for a second. It can be anything you want, but I'll go with this. Now let's say this symbol abstracts all the numbers. So this symbol could represent a 3, a 27, a negative 27.123, whatever you want. It's a placeholder for a number. If we don't know what the number is, we can use this placeholder until we find out what it is. Think of it this way. You're at a movie theater and you're thirsty. You go to the cashier and say you want a drink. So you give them your hard-earned money and they give you an empty cup. At this point, you haven't decided what drink you want yet. but you know you want a drink since you bought the cup. But until you choose what drink to get, the cup is just a symbol or an abstraction of your drink. So here we are using this symbol to represent numbers because we know it is going to be a number. Then we can use methods in algebra to learn more about the symbol to figure out what number it could be representing, and we'll learn more about these methods in future videos. This symbol that represents the numbers in a more abstract form, we call it a variable. And usually in algebra, we'll represent variables using letters. So let's do a couple examples in finding the variable. I encourage you to pause the video and try to find these on your own before I answer them. So in this case, we have 3 plus a. Well, 3 is just a number and a is a letter. We don't know what a could stand for. It could be anything. But until we know what it stands for, a is the variable of this expression. Next, we have 7 times b. Now, b is a letter, so we can point that out as being the variable, and 3 is a number, so it's not going to be a variable. However, you may notice a possible point of confusion here. We have 7 times b, but the symbol we've been using for multiplication until this point has been x. So, what do we do now? What if we want a variable that's the letter x? Well, if we have a variable that's the letter x, then it might be confused with multiplication. So what we'll be doing is we'll be using this symbol to denote multiplication. We use this little dot and it means the exact same thing. So 3 times 4 could be written as 3.4 and it would still be 12 because the dot means multiplication. And this allows us to use x as a variable without it being confused with multiplication. Alright, in this example we have 64 divided by c. So 64 is a number and c is the variable because c is a letter. And lastly we have a plus b. Now, actually, we have no numbers in this case, we just have a and b. We don't know what they are because they're both letters, they stand for some number, but we don't know what they are, so they're variables. So in this case, we actually have 2 different variables. Now this is important because oftentimes we'll actually have multiple variables in the same expression or equation. Now let's practice writing some expressions using variables. Leonard makes $50 per hour as a waiter. People can also choose to tip Leonard money if they like his service. Let's write an expression for how much Leonard makes in an hour. Because the amount people tip Leonard could be any amount, we need to express this as an equation with a variable, since we don't know the tip amount until he gets it. So the tip amount could be represented by t, where t is a variable. So for an hour, Leonard would get $50 because that's how much he makes per hour, plus t. If Leonard gets $10 in tips, we'd have 50 plus 10 is $60 for the hour. If Leonard gets $100 in tips, he'd have 50 plus $100 for the hour, which is $150. But we don't know what he'll get, so we'll use the variable t. Hilda has 5 fries. She wants to eat some. She could eat any amount of fries, but we don't know how many. Let's write an expression for how many fries Hilda will have after she's eaten some. So we'll use f for the amount of fries Hilda eats. It could be anywhere from 0 to 5. It can't be more, since the amount of fries she has is 5, right? It doesn't make sense that she eats 6 fries if she only has 5. Because she's starting off with 5, we can write the expression as 5 minus f, where f again is the amount of fries. If she ate 1 fry, f would be 1, and we'd have 5 minus 1 equals 4 fries left over. If she ate all 5 fries, f would be 5, and we'd have 5 minus 5 is 0 fries left over, which makes sense. If she ate 5 fries, she ate all of them, so she'll have none left. We don't know how many fries she'll eat, so this is why we use the variable f to account for this uncertainty. Alright, let's do one more. So Tina's going to give $100 to every homeless person she sees. So let's write an expression for how much money Tina is going to give out. Well, Tina could see 1 homeless person, or she could see 50 homeless people. We don't know. So we can make a variable to represent homeless people. Let's call it h. And we can write the expression as 100 times h. Remember, we're using the dot here, not the x. And the reason for this is if there are 3 homeless people, h is going to be 3, so she'll give $300, which is 100 times 3. If there are no homeless people, h could be 0, and she'll give no money, which makes sense because 100 times 0 is 0. So I encourage you to try and come up with some examples in the comments. The possibilities are endless, and being able to come up with examples is a great demonstration that you understand the material. The main takeaways from today's lesson are: algebra can be used when dealing with change and unknowns and can be used to represent patterns. Symbols are used to abstract a concrete idea and make it easier and more general to manage. We can use symbols to represent a collection of numbers if we don't know the exact value of the symbol. These symbols are often called variables. Variables are usually in the form of letters. And because x looks like the multiplication sign, we won't be using the multiplication sign so we don't confuse it with a variable. And instead we'll be using this dot to denote multiplication. I hope that was a helpful introduction to variables. If you had trouble understanding things, don't sweat it. I said a lot in this video. So maybe go back to certain parts if you feel the need to. If you want a different resource to explain how variables work, check out Khan Academy. They have a great explanation there. Well, that's about it, folks. Have a good one, stay groovy, and I'll see you in the next video.